Okay, this is going to be real informal. I just offered to fill in a spot here. I wanted to show you some recordings of some of the satellites that I've done with an SDR receiver, and let me show you the equipment real quick. I'm using a yes, thank you. These are my antennas in Florida here. You have a M2 CP30 for UHF, a 10-element horizontal Yagi for 2 meters, and a 3-foot dish with a patch feed and preamp for S-band, and then a 35-element for L-band. You can see I'm not in a perfect spot. I've got a lot of pine trees that resonate real nice at UHF. This is the equipment. You see the two Hamtronics receive converters. These are basically, let's see, this is the old one. So this is 435 in, 28 out, and this is 145 in, 28 out. And then this is the receiver here I'm using, SDR-IQ. It's about half the size of a small paperback book. It has a 192 kilohertz bandwidth, feeds via USB cable into the computer. Now I use WinRad, which is just another picture. WinRad is a really easy to use package. It's probably not, it doesn't have as many features as SpectraView, which is probably the one most people are familiar with, but I like it because I don't have to dig through menus to record and play things. Let me bring that up here. I got a little list here of some clips that I want to play for you. AO51 on VS. So this is the downlink from AO51. We want to open a WAV file here. These are just recorded as WAV files. And AO51 VS right there. So what we have on the screen here, if you haven't seen one of these before, this is frequency. Now it says 28,130 to 28,270, but this is being down converted 2 times. So this is roughly 2401,200 right in the center here at 28,200. And let me play it here. Don't mind this in the center here. That's just a birdie. Let me fast forward a little bit here. Okay, so we're starting to see some signal up here at the high end, and you can see some fades in it, and it's an FM signal, but it's just noise, so it's scattered. There's no carrier in the center of it that's visible. You see how fast the Doppler's moving on it? Right now we're centered, there's somebody kerchunked it, and you have a nice little carrier in the center. And we're moving pretty fast, about a kilohertz every 15, 20, 30 seconds here, moving down. We can go over here and click on FM. This is our bandpass here for the FM. I've got it down to about 300 kilohertz, or 300 hertz here. And if we click on it, you can hear somebody kerchunking it. I'll jump forward a little bit, see if I can. So one of the neat things about using an SDR is you can instantly see how much signal you're getting. Your noise floor here is about 120, and it's peaking around 95, almost 90. So you've got a signal 30 dB out of the noise. And it's real easy to compare how you have your station set up by looking at that over time. So let's open another one up here. I have an AO51 clip that was from field day. Now my antenna is left-hand circular and it's fixed. That's for the digital downlink on AO51. I just never bothered to put the switcher on it. AO51 field day. Now on field day we ran 2 repeaters, one L-band uplink on the 435 150 downlink, and then VU on the 300 downlink. What's interesting on this one is you can, first of all, I've got a rather cruddy signal. This was not a great pass. As you can see, here's the 150 downlink, and here's the 300 downlink. Notice the 150 is much stronger. We were actually running less power on that day, and that was because I'm left-hand circular there. And let's see if we can hear a little bit on one of these. We're still on FM. Not a whole lot there. I'm not going to search around for it. I just wanted to show you how you could watch more than one transmitter at a time. We'll stop that one. We have a pass on FO29. Select the input wave file. FO29. Second FO29. This one. Now, here on FO29, we're listening to a transponder satellite. You can see the beacon here, just a little bit below, let's see, that'd be 435.808 or so. And there's your CW beacon. This is interesting here. We have a lot of problems with 2-meter QRM from non-amateur stations in the States. This is an FM carrier with some brief modulation on it here. And that would be just about 146 or so. It may actually be an input to a repeater too on the uplink. See some sideband signals over here. The satellite's still pretty low to the horizon for me. Let's jump ahead towards the middle. So here we see the CW beacon still, and lots of voice QSOs on single sideband. You can see these wiggly lines here. Oh, okay. I'll try to use the mouse here instead of the pointer. You can see somebody tuning, trying to find themselves. You see lots of folks tuning all the way from one end of the passband all the way up to the other end. Let's see if we can listen into a contact or two in here. And we got somebody up here way up on the very high end that was probably being punished for being smart and not piling up in the center by having less contacts. So we'll go down here and pick upper sideband, and let's try this one. He's on CW. So you can see it's kind of funny that everybody's piled up in the center there. And neat thing about this is that this is preserved for perpetuity now. I can go back and listen to this file over and over again and hear everything that went on FO29 on that pass. So we also use FO29 to find QRM on the uplink for several of the FM satellites. Let me open one up here. Let's see, it is this one. This is FO29 again. This is back in December. We were having some problems with a carrier on the 145.92 uplink on AO51. It's pretty strong too. And it seemed to be coming from somewhere in the States. Well, I looked here on FO29. So if you're going up on 9.2, you're going to come down about 20 below the top, plus or minus Doppler. And here's a series of carriers. They're FM carriers because every once in a while you can see a burst of modulation that goes out on both sides. But you can see there's 3 of them, and they Doppler right through the uplink on AO51. Now we had a KA2 UPW was working on some of these to do some Doppler analysis and try to figure out where they were, and we got it narrowed down to an area, and about that time they disappeared. You also see some more FM stuff up here. These are likely Chinese-made cordless phones. You can buy them by the dozen on the internet, and they run 10 to 20 watts in the 2-meter ham band and above and below. They've been a real problem. We've found several of them on AO27. We had these for a while that some reason disappeared. Let's take a listen and see who this is. If you missed something, we can go back. So it's a good tool to have a transponder like that with a 2-meter uplink, despite 2 meters being easier here on the downlink because you can use it for other things. AO7, let's take a look at a file from AO7. Anybody that's operated AO7 has heard the noisy areas in the passband that especially well in mode B. Let's see here, 28.950, this one. Well, with this you can actually see them. So your passband runs from, 925 to 975. And here you see with no signals basically on the band, you've got 3 bands of QRM. And if we go and listen to one of these, oh, somebody on CW too. What I've noticed on this is that whenever you get a decent signal, these interference bands change. You see some signal in here, and they reduce. And I also noticed that this one is narrower, and then this one's a little wider, and this one's a little wider, almost like it's some sort of harmonic. And every once in a while, when somebody really hits it with too much power, it'll jump. Let's see, 142.15. So sometimes when it really gets nailed, these bands, you can see them all drift to the left usually as the voltage on the satellite's pulled down, and occasionally it'll reset the satellite and it may even come up in mode A when that happens. Wasn't too many people on this pass. Here's somebody. And back up a hair. So Kilo Fox 0 Zulu was on, but it doesn't look like he was getting any takers. So I just wanted to show everybody, if you haven't seen SDR as is applied to receiving satellite signals, it's a really neat tool. I expect it we'll start seeing more and more built into built into or designed to be hooked into your commercial receivers. The Yaesu HF stuff already has it as an option, and it's really a nice tool, even on satellite or regular terrestrial. It's nice to be able to see what's going on the whole band. Any questions? SpectraView. Yeah, that's Mo Wheatley's package. It does a lot more and has a little better display on it, I think, but it's a little tougher to use. At least for me, you have to dig a little more. He's got SpectraView running in the back if you want to take a look at it.
Yeah. Question over there. Your own download signal alongside the beacon, so you can actually see how much power you're putting in.
That's a good point. That's a great point. Yeah, you can use it for relative power. He said he's got a similar setup, and he uses it to make sure he's not stronger than the beacon and compare his own downlink signal strength to the beacon. That's great. That would have been nice with AO40. Hard to tell 10 dB by ear sometimes. Any other questions?
Another question over here?
WinRAD is a free download along with SpectraView. If you have a jump drive or a blank CD or DVD and are interested in any of these files, I'd be glad to give them to you. Thank you.